Sorry, I've talked too much this morning. I'm not very articulate here today. You can just cut it, you know. I'm Terry Plank. I'm a professor at the Lamont-Doherty Earth Observatory at the Climate School of Columbia University, and I'm a geochemist who studies volcanoes. All the way back to the beginning, becoming a geologist was inevitable. I was born in a rock quarry. And so from third grade, I had a rock collection, and my mother took me on field trips in the Delaware Mineralogical Society. I went to college to do geology, and I kind of got the volcano bug at Dartmouth College, where there was a big program to go look at volcanoes in Costa Rica, and never looked back. So volcanoes are portals to what's happening in the deep earth. And originally, that's why I was interested in studying the magmas that come out of volcanoes, to understand how hot the earth was, how plate tectonics creates volcanism. But as my career got on, I got more and more interested in the eruptions themselves. My research is really focused on the gases that come out of volcanoes, like water and CO2 and sulfur. There's been a new discovery that CO2 and the sulfur concentrations change a few weeks before eruption. And so it's a new precursor that we didn't know about a decade ago. And we're just developing the instruments that can measure these gases in real time. And we have a project that's trying to take that real-time data by satellite so we can bring it back from the field to any lab on Earth. The other awesome thing about being a geologist is that we have to study the Earth. So we have to travel. That's the best part of it. And the work that I do in volcanoes takes me all around the Pacific Ring of Fire. So I've worked not just in Alaska, but Nicaragua, Costa Rica, and the Eastern Pacific, and the Marianas and Tonga in the Western Pacific. And it's definitely a great perk of the job. GeoPRISMS is a multidisciplinary program to study Earth's destructive forces, earthquakes and volcanic eruptions, that aren't typically studied together because you need to be both out at sea and on land. And so GeoPRISMS provides an opportunity to connect the science that is oftentimes separate between the ocean and land. The awesome thing about the GeoPRISMS program is that it has been running a series of sustained workshops and conferences like the one we're having here in Montana. And it's hard to overstate how important these meetings are. When you're there, you're just talking to people in the heat of the moment, exchanging ideas, but it's sometimes not years later till you realize, oh, I made that connection, or this gave me an idea proposal, or I developed a new collaboration or had this new idea, and I'm so excited to hear what's going to come out of this meeting. The GeoPRISMS program is a 10-year program, and it's come to an end, which is sad because it's been such an exciting incubator for ideas. But we're excited there's something on the horizon, a new program called SZ4D, that's subduction zones in 4D, so 3 dimensions plus time. And we're hoping this is going to lead to the next generation of students and postdocs making new discoveries on volcanoes. Earth science is the best field to be into. Most high school students don't know about earth science, but I tell you, I teach at a university, and so many students will take their first earth science course and say, like, where has this been? I want to be an earth scientist. It brings together chemistry, physics, biology, math, and then being in the field and studying processes that are happening actively. I don't know a geology student in our department who is unhappy. It's a field that people discover and love, and it's a field that has lots of jobs. There's going to be no shortage of jobs in a world of natural hazards and climate change. Be a geologist.